So good morning, everyone, and welcome to today's session. Well, in the previous session, we had started something known as work energy theorem. Do we remember this work energy theorem? Anyone? Do we remember this work energy theorem? Yes or no?
Yes, sir.
What was this work energy theorem? What does the work energy
All
theorem?
force equals to kinetic energy. Change in kinetic energy.
Right. Whenever a force does any work, that work will always come if that work is done on an object, that work will always come as change in kinetic energy. That will always come as change in kinetic energy, and we had seen some examples of that work done. We had seen examples where we had different forces. We had gravity, we had normal reaction, we had friction, we had applied force, and we had seen how do we find out the work done by all these forces. We have already done that, and then we saw how do we find out the change in kinetic energy. Now let us continue with that same concept and do some questions quickly. Now it all depends on how quickly you can solve them. If you can solve them pretty quickly, I can do more questions. If you can't do it, then I will have to do less ones because I can't keep um, dragging this topic for long. So if you don't do it fast enough, what I will do is I will reduce the number of questions and I will move ahead. So it all depends on how quickly and how much questions you can do. So this is the first one in today's category. I have this angle as theta. Let us say I have the height of this wedge as h, and I have a body of mass m kept here, and the body is at rest. The body is at rest. Now, this body, as I am telling you, is going to move down. Is going to move down. The coefficient of friction. The coefficient of friction is mu. The coefficient of friction is mu for this body, for the surface and this body is going to move down. If I call this position as point A, when the body reaches point B, when the body reaches the bottom of the track, point B, you have to tell me what is the velocity or the kinetic energy, whatever you call it, of the body when it reaches point B, which is the lowest point of this wedge. I will give you 2 minutes, 2 minutes to solve this question and give me the answer fast. Okay, so how are we supposed to do this? I think you have tried. Uh, you will have to find out the work done by the forces which are acting on this block. Can anyone tell me what are the forces acting on this block? Can anyone tell me what are the forces acting on this block?
Force.
So, yes, tell me what are the forces acting on this block?
Frictional force.
Frictional force,
Gravitational force.
gravitational force,
Normal force.
normal reaction force. Anything else? Okay, what is the work done by normal reaction here?
Zero, sir.
Work done by normal reaction is zero. Why it is zero?
So it is perpendicular, sir.
It is perpendicular. What is perpendicular? Force and displacement are perpendicular. Okay, well done. What is the work done by gravity?
Zero.
Work done by gravity is plus mgh. The block moves down from top to the bottom. Whenever gravity does work, that work is equal to mg multiplied by the height. If it comes down, it is positive. If it goes up, it is negative. I have told you that many times. I hope you remember it. What is the work done by friction? Anyone? What is the work done by friction? How do I get the work done by friction? Can anyone tell me the formula? We'll have to do we
Into
need to look at the formula of work done? That means we are not doing so good.
force into
Chapter is
displacement.
going to finish in 2 days and we still don't know the formula of work done. Yes, please tell me what is the formula of work done?
Force into displacement, sir.
Force into displacement. Anything else that you want to add there? Okay, thank God that we know this, that it is force into displacement into cos theta. Great, thank God. So this is kinetic friction multiplied by the displacement or distance multiplied by the value of cos theta, where theta is the angle between force and displacement. What is the angle between force and displacement? What is the value of this cos theta? I should not call it. I should not call it cos theta. Let me call it cos phi. Yes. What is the value of this angle? What is the angle between force and displacement here? I'm not able to get you, but I think you are saying it as negative -1. The angle is 180 degrees. Yes or no? Thank God. Chalo. Now, how much is the frictional force here, beta? Can anyone tell me how much is the frictional force?
Mu mg.
Okay, frictional force is mu mg cos theta, mu into n is mg cos theta. I don't know from where you are getting this mu mg. Okay, so mu mg cos theta, we have done it 1500 times. We have found out the value of friction. Mu into n, this is mu into mg into cos theta. How much is the distance that this body has moved? It has moved from this point A to this point B. This is the displacement or the distance. Yes. How much is this? This is given as h. This is given as theta. Can you tell me how much is d? Okay, no one knows it. Must be a very difficult question. H by d, my dear friends, is something that we call as sine theta. Do you remember sine theta, cos theta, tan theta? H by d is sine theta. Please remember it. If you have forgotten it, please remember it. Then your d becomes h by sine theta. So you just put the value of d here and put a negative sign because of this cos, this angle. That is the work done by friction, my dear friends, multiplied by h divided by sine theta. So it becomes minus mu m g h into cot theta. Now I can find out the kinetic energy of the block or the velocity of the block. How I will do it? I will apply WET. WET means work energy theorem. I will apply this work energy theorem from point A to point B. Work energy theorem states that work done by all forces is equal to my change in kinetic energy. What is the work done by all the forces here? We have the work done by gravity, which is plus mgh. So I just write it plus mgh. Then we have other work done by friction, which is minus mu mgh cot theta. So I write that work minus mu mgh cot theta. that must be equal to change in kinetic energy. When I say change, it is half mv square final kinetic energy minus 0, which is the initial kinetic energy. Now I can cancel out the things which are common, and I will get the value of V. What will be the value of V that I will get? I will get something like this, my dear friends. 2 times G H into 1 minus mu cot theta. That was the answer that I was looking for. I am quite disappointed I could not get that answer, but it's okay. So I'll give you 2 minutes to please note it down, and please let me know if there is something that you have not understood. So here comes the next question, and I hope that I would get an answer for this one. A sphere is suspended from the point O by means of a string. This is a string, as you can see. This is a string of length L, and it is suspended by a string. It is released from the horizontal position as shown in the figure. When it reaches the lowest point, you can see the lowest point, point B, it has got some velocity, u. You have to find out the velocity u at the lowest position. And I'll give you 2 minutes to give me the answer for this one. Okay, then let me help you in solving this. What are the forces working here? Can anyone tell me what are the forces working here? Does anyone know what are the forces working here, beta? There are two forces working here. Can you tell me what are the forces working here?
Tension and gravity.
Tension and tension and gravity. These are the two forces working here. So we have to find out the work done by gravity, and we have to find out the work done by tension. Remember, whenever there is a question, they ask the velocity. 99.9% that question has to be done with this work energy theorem. So this is the hint that you get from any question. If in any question they have asked you what is the velocity, 99.9%, maybe even 100%, that question has to be done with the work energy theorem. So you apply work energy theorem and you get your answers. Can anyone tell me what is the work done by tension here? No one knows it? Okay.
Sir, zero.
Yes, beta? Work done by tension? Okay. I can't hear you. Yes.
0, sir.
Work done by tension is 0 because this tension is always going to be perpendicular to this displacement. It is going to move in a circle. Tension is going to be perpendicular. That's as good as it gets. What is the work done by the gravity? By gravity. How much work gravity does here? The ball moves from point A to point B. Can anyone tell me what is the work done by gravity? Yes, beta? Can't hear you. And can anyone tell you what is the work done by gravity? Okay? I don't seem to get your voice. Work done by gravity, we only have to see how much it has moved up or how much it has moved down. How much it has moved down here. So the work done by gravity is plus mg, and it has moved down by a height L. So work done by gravity is plus mgl. That's it. Now I can apply the work energy theorem from point A to point B. I first write that theorem. Work done by all forces is equal to change in kinetic energy the work done by all forces, there is only one force doing any work, plus mgl, that should be equal to change in kinetic energy. Half mv square is the final kinetic energy, 0 is the initial kinetic energy. From here I can get the value of v. V will be equal to under root of 2gl, and that is the answer that we were looking at. Anyone got this answer? Okay, I see a lot of people getting the answer. Great, that is good. I'll give other students 1 minute. So, my dear friends, the next heading that we are going to write is known as potential energy. Does anyone know what is potential energy? And does anyone have any idea about what is potential energy? Potential energy, my dear friends. Yes? No one knows it? Okay. So, what is potential energy? Potential.
The body
Yes?
Indian position.
I heard position. So, I hope that you are saying this. This is the energy acquired by a body. Energy acquired by a body by virtue of its, the virtue of its position, or I can say configuration, how it is placed. It is the energy acquired by a body by virtue of its position, or I can say configuration. Now, this potential energy, which is normally denoted by the letter U, this potential energy, normally denoted by the letter U, is always associated. This potential energy, which is denoted by U, is always associated with a conservative force. Whenever there is a conservative force, this potential energy will come wherever there is a conservative force. Does anyone remember what is this conservative force?
Does not depend upon path.
Well done. This conservative force is a force whose work done does not depend on path. So this potential energy is always associated with a conservative force. Whenever and wherever you have a conservative force, you have potential energy. Now, remember the absolute value of potential energy is not defined. This absolute value of potential energy is not defined. Note it down that this absolute value of absolute value of potential energy is not defined. Then what is defined? The change or difference, not change of, change or difference in gravitational potential energy is defined. The change or difference in gravitational potential energy is defined. And how is this change or difference defined? Change in gravitational potential energy is defined as negative of work done. That is nothing but negative of work done. If an object moves from 1 to 2, point 1 to point 2, it is defined as negative of work done by the conservative force. This is how change in gravitational potential energy is defined. Now, what do you mean by this? For example, you have this point 1 and you have this point 2, and you move an object from point 1 to point 2. If I call the energy of this point as U1, if I call the energy at this point as U2, I am moving an object from 1 to 2 by a conservative force. This conservative force does some work. The change in gravitational potential energy, change always means final energy minus initial energy. That will be equal to negative of the work done from 1 to 2 by the conservative force. This is how change in potential energy is defined. Do we understand this? This is how change in potential energy is defined. I hope everyone has noted this down. Everyone has noted this down. Now remember the important points about this potential energy. Everybody noted down up till there? The first point is potential energy is only defined for conservative forces. Non-conservative forces, there is no meaning of this potential energy. It's only defined for conservative forces. And there are three conservative forces or three potential energies that we will be encountering. Can anyone tell me what are the three potential energies that we are going to encounter? The three types of potential energies that we are going to encounter. Some in this year, some in the next year. Can anyone tell me what are the three types of potential energies that we are going to encounter? No one knows it? Okay.
Spring potential energy, sir.
Okay, and that is one. I said three. Okay, the first type of energy, delta U, that will be equal to U2 minus U1. That will be negative of work done from 1 to 2 by gravitational force or gravity. This type of energy will be known as GPE. GPE means gravitational potential energy. That is the first type of potential energy that we'll encounter. The second type of potential energy that we will encounter, again, change in this potential energy will be negative of work done from 1 to 2. Now here gravity is not there, electrostatic force is there. So this will be known as EPE, electrostatic potential energy. The third type of potential energy that we'll encounter, again the same definition, same everything. But now it would not be gravitation or electrostatic, it would be spring potential energy. Spring potential energy. So these are the three types of potential energies that we are going to encounter. Gravitational potential energy, electrostatic potential energy, spring potential energy. We have noted this down, everyone. Yes or no? No, yes. Well, this potential energy, it could be positive, negative, depending on the choice of reference frame. Remember, this absolute value is not defined for this gravitational potential energy. Absolute value is not defined for gravitational potential energy. Only the change or difference is defined. To get the value of potential energy, a reference point is taken. Whenever we talk about this potential energy, always we will have a reference point which would be taken, whose potential energy is taken as 0. Without taking this reference point, you cannot find out the potential energy of any other object, any other point. So we need a reference point to find out the energies, and depending on this reference point, potential energy can be positive or negative. Example, if this is ground, if this is ground, and I take the gravitational potential energy of ground as 0, so my ground becomes my reference point. Then, in that case, the gravitational potential energy of this point or this mass becomes how much? Anyone knows it? It becomes plus mgh. This is how we take for gravitation or gravity. This is how we take one reference point. We call the energy of that reference point as 0. Then we can find out the energy of anything. So here it becomes positive. Now, if I have another point here, and it is at a distance, let us say d, below ground, what would be the gravitational potential energy of this body, this mass?
Minus mgh.
It will be equal to minus mgh. So, depending on where I have taken my 0, gravitational potential energy can be positive or negative. Same example, but done in a different way. I still have this point, m. Height above the ground is h. I still have this point, m. The depth below is d. But now I take the gravitational potential energy of this point as 0. I take the gravitational potential energy of this point as 0. Now can you tell me what would be the gravitational potential energy of this point? Yes, that is correct. It will become plus mg into h plus d, because now the height from the 0 point is h plus d. So you can see gravitational potential energy can be positive or negative depending on the choice of reference frame. Everyone understands this? So this is going above our head saying bye bye. Bye bye, I'm going. Now one more point you would have seen even here. This is the next point. Gravitational potential energy changes because of the change in reference frame, but the change in potential energy is independent. If you can find that difference, if I call this point as point A and if I call this point as point B, the difference between A and B will always remain same, as you can see here. A it is a high, A it has at A is at a higher potential, B is at a lower potential. The difference in potential energies between A and B will always remain mg into h plus d. It doesn't matter which point I call 0 or which point I call not 0. The difference in potential energy does not depend on the reference frame, and that is why the difference in potential energies is defined. I hope everyone is understanding this. Yes or no? Everyone understands this? Difference remains same no matter where you place your 0. Doesn't matter. I will normally place my 0 at the ground level. If there is something below 0 also, I will place my 0 at the lowest point so that everything is positive. I don't like negatives in my life. So I will not try to call any energy negative unless it is really necessary to do that. Now potential energy is a property of an entire system. So you change anything in that system, any object you change, the potential energy actually changes. So that is, again, this is just for your academic purpose. You may not get any question on this. The last point but not the least is that this gravitational potential energy does not depend on path. Everyone understands that this does not depend on path. Yes or no? No, yes. Everyone understands this? Okay. So this is the gravitational potential energy, the concept of gravitational potential energy, when it is positive, when it is negative. We'll also try to see the concept of spring potential energy. But let us first do some important things. Have you noted this down? Everyone has noted this down? Okay. Okay, now this is a small exercise. I don't want you to waste much time onto this. This is a rod of length L, which is kept straight like this. And the question is, you calculate the potential energy of this rod, and it's given that ground should be taken as the zero energy level. The energy of ground should be taken as 0. Then what is the potential energy of this rod? I will not want you to waste any more time on this. So you will have to just find the center of this rod, and you just have to find out the height of this center of the rod from the ground, which is taken as your 0 energy level. And then you can say the potential energy of this rod standing straight will be equal to plus mgl by 2. So you can just draw this diagram, mark the center, and write that the potential energy of this rod is plus mg into L by 2. Do we understand this? There is no point of doing the derivation. You can just remember the result. That is more important than anything else. I'll give you 2 minutes to note it down. Note it down fast. Well, then we move on to the next thing. Instead of this rod being vertical, if the rod was making an angle like this, case number 2, if the rod was making an angle like this, and I again say that the potential energy of ground is 0, can you tell me what will be the potential energy of this rod if it is at an angle theta like this? What will be the potential energy of the rod if it is slanted like this at an angle theta? Yes? Again, you will have to find out the center of this rod, and you have to find out how high is this center of the rod is. How high will the center of the rod be? This distance is L by 2. How much will be the vertical distance? Can anyone tell me? No one knows it? Okay. It will be L by 2 sine theta. This vertical distance will be L by 2 sine theta. So the potential energy of this rod will be plus mg into L by 2 sine theta. Plus mg into L by 2 sine theta. I hope everyone is noting it down. Everyone is noting this down, yes or no? Then everyone has noted this down. Then we move on to the third type of diagram. This could be a ring. This could be a disc. This could be a sphere. This could be a cylinder. Mass m and radius r. And the reference line, the zero energy line, is the bottom line. Can anyone tell me what will be the potential energy of this body? Ring or disc or sphere or cylinder? Can anyone tell me what will be the potential energy of this body? The potential energy here is taken as 0. Can anyone tell me what will be the potential energy of this body? This is the center O. Can anyone tell me what will be the potential energy of this body? No one knows it? Okay, not a problem. It will be equal to plus mg into r. I just have to find out the center, where the center is and how high the center is from the bottom line. One more last, and then we can call it a day. If you have a chain which is put like this, I don't think we will be doing any questions on this, but just for your reference, if there is a chain which is kept like this on a semicircle, how do I get the gravitational potential energy? This is case number 4. Again, I had to locate where is this center line, and you must remember that the potential energy of this, the height of this center from this line, from the ground horizontal level, is 2r by pi. It's 2r by pi. So the energy becomes plus mg into 2r by pi. You must remember these standard results because they are going to help you in solving some difficult problems very, very easily. So on that note, I will wind off this class. In today's class, we have discussed the concept of potential energy, and tomorrow we will go ahead and solve some problems on this. Take care and God bless all of you. I hope everyone has understood what we have discussed in today's class. Everyone has understood the concept of gravitational potential energy? Yes or no? Well done. Then we will see you in the next class. Take care. God bless all of you. Bye bye.
Thank you.
Bye beta.